Good evening again, City Council members, Mr. Mayor. This past fall, facilities staff, in doing a visual inspection of some sort at the Hamilton Lowe Aquatic Center, discovered several anomalies, if you will, in the roof structure support system at the building. And upon further investigation, we uncovered numerous areas of existing rot, dry rot, that appeared to be from water infiltration. Subsequently, the city then contracted with Reliant Engineering of Pullman, Washington, of whom the principal is Evan Lowe, who's here with me tonight. And at this point, I'd like to turn it over to Evan, as he has the expertise in this manner and has prescribed the procedures in which to move forward to get this structure repaired, safe, and open for the public this coming June. Evan?
I'm Evan Laubach, and you understand that I'm from Reliant Engineering, and I'm the principal. And you need an address, is that right?
Please.
248 Northwest Sunrise Drive, Pullman, Washington.
Thank you.
I guess one of the first things I want to portray is that, or get across to the council and mayor, is that there's pretty widespread consistency of what's going on. This isn't an isolated case of we had one bad beam that had some bad wood in it and had some rot going on or something like that. It's consistent from the north side of the building to the south side of the building, from the east end to the west end of the building. And like I say, it's consistent, and I'll show you a series of slides that represent that. And unfortunately, for the city of Moscow, the same year this building was built, the code went through a change just after the building was built, and no longer allows the use of glue-lam beams in an exterior application. And all of the deterioration that we see is in glue-lam beams that are exposed to the weather. And so we went through a code change from using the UBC system to the International Building Code System, the ICC, or the IBC is this particular code that governs this building, in 2000. And so that's kind of where some of that transition took place. So it was an identified problem that was known in the industry, but it didn't make it into our codes and the design criteria that engineers and architects were using until after this building was built. So that's a little bit of history of kind of why we got to where we're at with this. This is obviously what we have here is the front entry. The upper part is the overall entry there, and you can see that there's at these joints here where the beams come over, the rafters come over the beams. We've got rot showing up there, and you can see it there. And then this lower picture is actually the back side right in this area here. And this is from water kind of sitting on top and running down through some cracks in the top and actually rotting out clear down one of the lambs even lower there. In this case, the front entry, after some calculations, we've determined that we can actually live with the beam, and we will be able to do some structural repairs in place and not have to do anything with it. This is the east end of the building. This piece right here is a structural truss that actually supports then these beams that come out and the ridge beam that comes out here. And that area right there is this area right here. That just happens to be a screwdriver that I shoved in there, and you can see the length of that in relation to the depth of the beam here. We're going 2/3 of the way through that beam in just soft material that's in this seat here. And that's a structural component that's actually holding up a lot of this end of this building here, of the shade structure. And then here you can see in the main support beam here, there's this significant deterioration here. Here's a close-up of that same deterioration that's going on. And you can see that it's well over 50% of the way through here. And each one of these plies that you see here, that ply, is each an inch and a half in thickness. So you can see that, you know, we're 7, 8 inches down into the member here where we still have lots of deterioration going on. Then these are the support columns, and we have some issues going in at the bottom. Here's an example of that where this is all rotting out here in the base of this column here. So one of the other things that they did is the contractor used the improper washers. And so what they did is, in order to get compression in the bolts, they squished the actual wood, which isn't real relevant or real obvious here, but it depresses these bolts into the wood, creating cracks and openings where moisture was getting in and then deteriorating this. So part of our part will be to replace the bolts here with proper washers in that instance there. This is just a little bit farther down the beams, and you can see where just about every single segment of this horizontal beam on the south side has major deterioration in it and large enough pockets in it that we're not able to salvage any of it. And then one of the other things that's going on is they put some flashing on the tops of these, but in a lot of cases they didn't seal them properly in that, and you can see that water's getting in underneath these flashings and causing rotting and deterioration underneath the flashings. And in a couple of cases where we had the longer runs on these, the lapse on the sheet metal was actually done in reverse, so as water ran down the tops of these, it would run underneath the flashing. One of the other things that they did is this continuous flashing that is underneath here. In a few cases, they have the lapse backwards in the flashing, so as water runs down and down the drip lip, it can go in the joints and run back in underneath the flashing also. So just more of the deterioration that's going on here where we have the whole ends of some of these beams that are deteriorating. This is another one of those pockets in the beam. This is a close-up of that pocket, and as you can see, we now have insects settling in here. Here's deposits of insect borings here, and then we have yellow jackets then obviously building their nests in there also. And as you can see, here's rot from this end of the building, and we've shown you clear to the other end of that there. And then in the tails of some of the beams, we have complete deterioration. That's basically 4.5 inches of the bottom half of that beam is gone off the bottom of that. That's completely rotted, and it's gotten clear up into another 1.5 inches up into there, into that beam. And then here you can see where the seat completely rotted out, and then the water wicked up into the end and just completely ate out the material there. And then what we're showing here is that this beam is the center beam over the entry as you come in through past the ticket gate and head straight to the pool. This is the larger span of the beam that comes into that area. Or covers over that area and supports it. This beam was designed at max or possibly even, depending on how you look at it, it could be either right at max or slightly overstressed, which in wood materials I'm not that worried about being slightly overstressed, but in this case where then we have the wood deterioration taking place, I think you can see that from this point to that point, we have a significant bow starting to show up in this beam here, as in a sag from this joint to that joint. And that's what I'm trying to show in that picture. I hope it comes across. But and so when we replace this, we're actually going to upsize the beam that's going in there across this entry area. So then up above there is a relight section that is open. You can kind of, well, I just hit the wrong key there, didn't I? Let's see. Sorry about that. Now, how do I get back to going, which full screen? What did I hit?
I have no idea.
Why don't you help him out, Bill? Can you help?
There we go, I got it back. Whatever I did, I got it back.
That's where we started.
Sorry about that one. We can at least get back to this here. So anyway, this is the pool yard out here, and the roof that we've been talking about down below. And over the front entry, there's this raised up roof section with the beams sticking out and exposed, and there's a little bit of open area down into the entry area. And these are the tops of the beams here, and you can see the lichen growth and all of that that's going place. So obviously there's moisture sitting on the top of those, and you can see where water's wicking in, and it kind of flows down and gets into a bad spot here where water's sitting. And you know, even after the rain had been gone and everything else is dried out, you can still see moisture still sitting here in this. This is one of the beams that sticks out on the end of that relight and the vertical columns, and you can just start to see where all the deterioration is starting to set into all of this. In this scenario, we have a plan to be able to remove the ends of these beams and remove these ends, still maintain the structural integrity, and enclose all this area to protect all of this. And then this is part of that vertical framework structure that is along this face right here. This is one of those columns that's there. And what we're showing here is that there was a contractor deficiency. He didn't quite have a long enough beam here, and that is your bolt right there, okay? It doesn't actually even go through the beam. And it just so happens that in strong wind applications, this beam here is one of only 3 horizontal struts in this whole roof system over the front entry that holds this back. This is a tension member. So if it was applied in compression, which it can, it would push against the bolt, but there's applications where there's tension on this, and that would just pull out of there, and obviously there's nothing holding it in. It would pull out. Fortunately, we haven't had any of those strong wind events since the building is built, or that area just hasn't seen them. So we're very thankful in that respect. And so part of the proposed project is to replace these beams with long enough ones and get them properly bolted in there. And then this is just the original architect called for flashing in this area, and there's no flashing. This is this joint right there, looking in from the inside, looking back at it. And they just folded the roofing over it. And it's hard to see, but you can see where this lumber is all grayed and deteriorated there. And in the process, we will enclose that and remove that issue that we have there. And so what we're proposing then is a semi-clear product that basically this is a very, we happen to come up with the solution, and then I happen to be on vacation of all things, and I pulled into the parking lot and I go, that's exactly what we're going to do. And so I snapped a picture of it purposely to share. But that is that we have the roof system and the curved roof scalloping that we have, and basically these are actually infilled with a solid panel, but it will have a very similar look. It'll be a milky white product that sunlight will still fully come through, but it will cut down on the glare of the sun, and it would be an infill panel that will go over. This then will provide the extension of our roof and cover over all the other exposed glue lams and exposed framing and the sort there. So that's kind of the scope of the deterioration and the scope of what we want to propose to do. That relight that will be up there, that will also be done with the same panels. So we'll still have the original architectural feature of the light coming in, but just not have the weather coming in. And kind of to speak to the architectural side of things, I am an engineer, but I do have formal training in architecture. I started my college career in architecture and switched majors, and then I worked in an architect's office for 7 years. And then on top of that, during the process of this design, I brought an architect on my staff, or on my tab to come over and give his review of that. And he's been in the commercial realm for many years, and had him give his input to make sure that we weren't altering the overall aesthetics of the building and changing it to a point where, you know, there might be some question about that. And we feel very confident that we have a plan that addresses that very well. And in fact, a couple of the details that we're going to include in this mimic some of the stuff on the other event center that you have right adjacent to it, such as up at the Relight. We will be finishing the eaves off more closely to the way that they're finished off over there, too. So we don't feel like we're taking away from the original architecture of the building, but we are providing a building that will sustain itself well into the future. And that's one of the things, is we could go in and fix these. We could go in and replace them with different types of beams, things that might be more weather resistant. But in the end, as you can see, and in some of our interview process, we kind of questioned the city on how often they were maintaining it, how often they were painting it, and that kind of thing. And they actually have a very good program of, you know, of maintaining the wood, but it's just not a wood that works very well exposed to the weather, and so it deteriorates faster than their program can keep up with it. And so with this new proposed system, we will be providing a much lower maintenance facility that should live long into the future.
Walter, Senior